Somewhere in Boulder, Colorado, a machine does nothing but count. It does not think. It does not sleep. It does not interpret what it sees. It counts the vibrations of cesium atoms. 9,192,631,770 oscillations per second. That number defines a second, and because atomic clocks can measure time with almost impossible precision, they can detect things no human body would ever notice. In 2022, they noticed something strange. Earth had finished a rotation too early. Not by an hour, not by a minute, not even by a full second. By 1.59 milliseconds. A fraction of time so small that your brain cannot feel it. But to an atomic clock, a millisecond is not nothing. It is a signal. On June 29, 2022, Earth completed one full rotation in less than 24 hours. It became the shortest day recorded since precise atomic timekeeping began. And it was not alone. Records had already been broken in 2020 and again in 2021. The planet kept shaving tiny fractions of time off the length of a day, as if something invisible were pressing on the accelerator. That is not how the story is supposed to go, because over the long history of Earth, the planet should be slowing down. A day is not simply a number on a clock. It is the physical duration of one complete rotation of Earth on its axis, and that duration has never been fixed. When Earth was young, a day may have lasted only a few hours. Then came one of the most violent events in planetary history. A Mars-sized body, often called Theia, slammed into the young Earth. That collision altered its spin, tilted its axis, and blasted material into orbit that eventually became the Moon. Every sunrise you have ever seen is connected to that ancient impact. Since then, Earth has been gradually losing rotational energy. The main reason is the Moon. The Moon's gravity pulls on Earth's oceans, creating tides. But Earth rotates faster than the Moon orbits, so those tidal bulges are dragged slightly ahead. The Moon pulls back on them, creating friction. That friction slowly drains energy from Earth's rotation. The result is measurable. The Moon is moving away from Earth by about 3.8 centimeters per year. And as it moves away, Earth's rotation slows. When dinosaurs walked the planet, a day lasted only about 23.5 hours. In the far future, days will be longer still. That is the ancient trend. The Moon is breaking the Earth. But right now, the clocks are telling a different story. Earth is speeding up, so the question becomes unsettlingly simple. What is overpowering the Moon? The answer is not one force. It is many, acting at the same time. And the search for them takes us somewhere unexpected. Straight down. More than 3,000 kilometers beneath your feet lies the outer core. An ocean of liquid iron and nickel, hotter than the surface of the sun, moving under pressures no machine could survive. This churning metal generates Earth's magnetic field. It helps protect the atmosphere from the solar wind. It helps keep the planet habitable. But the outer core also interacts with the solid mantle above it. They are not perfectly locked together. The core and mantle can exchange angular momentum. If the flow of liquid iron changes, if it speeds up, slows down, or shifts direction, the rotation of the crust can change slightly in response. Scientists call this core-mantle coupling, and some researchers believe it may be one of the reasons Earth has recently been spinning faster. But the mystery goes deeper still. At the center of the planet sits the inner core, a solid ball of iron and nickel, roughly the size of the Moon, surrounded by the liquid outer core. For decades, scientists believed it rotated slightly faster than the surface. Then, in 2024, a study published in Nature found strong evidence for something remarkable. The inner core had been slowing relative to the surface since around 2010. It had decelerated so much that, compared with the planet above it, it now appeared to be drifting backward. Scientists cannot observe the inner core directly. Everything we know comes from seismic waves, the echoes of earthquakes, passing through the planet and returning with clues hidden in their timing. But something down there has changed, and when the center of the planet changes, the effects ripple outward, through the core, through the mantle, through the crust, and eventually into the measured length of a day. Earth's rotation is not controlled only from below. It is also shaped by what happens on the surface. At the poles, ice is melting. Greenland and Antarctica are losing hundreds of billions of tons of ice every year. That water flows into the oceans and spreads around the planet. This matters because rotation depends on where mass is located. A figure skater spins faster when pulling her arms inward. Earth follows the same physics. But here is the paradox. When polar ice melts and water moves toward the equatorial oceans, mass shifts away from the rotation axis. That should slow Earth down. And over the long term, it likely will. But right now, Earth is still spinning faster, which means the forces accelerating the planet, particularly from the deep interior, are currently stronger than the braking effect from melting ice. For now, as ice loss accelerates, that balance may change. The atmosphere is also part of the story. Air has mass, winds carry momentum, jet streams, pressure systems, seasonal temperature shifts. All of them move mass around the planet. When major wind systems speed up or slow down, they exchange angular momentum with the solid Earth below. The planet breathes and the clocks can detect it. Then there is us. Human civilization has moved enough mass to leave a measurable fingerprint. Groundwater pumped from deep aquifers makes its way into rivers and oceans. Large dams hold back water that would otherwise flow toward the sea. Each effect is individually tiny, but across decades and billions of people, it becomes measurable. We did not intend to affect Earth's rotation, but by moving water, reshaping landscapes, and changing the climate system, we have become part of the signal. This is the real story the clocks are telling. Not that one single thing is wrong with Earth, but that Earth is not a rigid object. It is a layered, moving, breathing system. The core speaks to the mantle. The mantle shapes the crust. The oceans move heat. The atmosphere shifts mass. Ice melts. Water flows. Humans pump, dam, burn, and redistribute weight across the surface. And all of it is written into the length of a day. You will never feel 1.59 milliseconds vanish. No sunrise will look different. No shadow will move fast enough for your eyes to notice. But the clocks notice. The satellites notice. The scientists measuring Earth's rotation notice. The 24-hour day is not fixed. It is a compromise, constantly renegotiated by the moon, the core, the atmosphere, the oceans, the ice, and us. Right now, Earth is spinning faster than expected. One day it will slow again, and somewhere, an atomic clock will be counting when it does. Because the rotation of this planet is not just timekeeping. It is the running record of everything that has ever happened to Earth, written in milliseconds.